Good afternoon, students. Am I audible? Okay, so next topic is your computation of critical depth. First, we are going to consider rectangular channel. Okay, so we have considered a rectangular channel. Width of the channel we have considered B. Okay, it's a capital B is your width of the channel. Okay, so capital B we have considered as the width of the channel, and critical depth we have considered YC. Okay, for a discharge Q. Okay, so this is your rectangular channel. The depth of flow we are going to consider as a critical depth, that is your YC, and width of the channel we have considered B, and T is our nothing but your top width. So we all know for rectangular channel your bottom width and top width is same. Okay, your bottom width and top width will be same. Okay, so area for a rectangular channel is nothing but width of the channel multiplied by depth of flow. Okay, so for depth of flow here we have considered critical depth. So that is why B multiplied by YC. Okay. Top width is nothing but your B value. As we know, your top width and bottom width of a rectangular channel is same. Okay. Then another term, this is called Q, small q. Okay. Small q is nothing but your discharge per unit weight. Discharge per unit weight. Per unit weight. Okay. Unit width of the channel. Okay. There is nothing but Q is a discharge divided by B. This is your denoted by small q. Okay. Small q is nothing but your q divided by small b. Sorry, capital B. Okay. Discharge divided by width of the channel. Okay. So now I think we have already derived this equation for critical flow condition, that is your q square t by Ga cube. Q square t divided by Ga cube. So this expression we have already derived. Okay, is equal to 1. Okay, so we are going to consider this equation. So once you consider that critical flow condition, am I audible? Okay, okay. Thank you, thank you. Okay. So once you consider the critical flow conditions, okay. So here we have this q square t divided by gaq, okay, is equal to 1. Okay. So next, in place of top width, that is your t, we can also write q square, your bottom width of the channel, okay, divided by g, that acceleration due to gravity, multiplied by area. Okay, area is nothing but our, we have already discussed this. Area is nothing but, for this case, width of the channel multiplied by yc. Okay, so in place of area we are going to substitute this b multiplied by yc. Okay, then we have cube here, a cube, so it will be b cube multiplied by yc cube is equal to 1, is equal to 1. Okay, so if you see this b, and from here one b will be cancelled out, so that is why what will be left out is q square divided by g b square, okay, and then yc cube, yc cube is equal to 1, okay, is equal to 1. So as we are going to find an expression for your critical depth, so what we are going to do, we keep this yc in one hand, or you can say in the left hand side, okay, and all the other terms will bring in the right hand side. Okay, so from this equation you can see yc cube is equal to q square divided by gb square. Okay, okay. Yc cube is equal to q square divided by gb square. Okay, so now if you see, we have a term called discharge per unit width, that is small b. Small b is nothing but q by b. Okay, so here if you see here in this equation we have q square, we have b square, so q square divided by b square, so we can directly write here yc cube is equal to small q square divided by g. Okay, or you can write yc is equal to q square divided by g to the power 1 by 3. Okay, q square divided by g to the power 1 by 3. Okay, so you write down the whole steps. Okay, so for critical depth of a rectangular channel, this is the expression yc is equal to q square divided by z to the power 1 by 3. Okay, and you consider this is number equation 1. Okay, so computation of critical depth for a rectangular channel. If anyone asks you to find the critical depth of a rectangular channel, you are going to use this expression. Okay, that is q square divided by g to the power 1 by 3. That small q is nothing but distance divided by width of the channel. Okay, okay. So now if we consider the specific energy at critical depth or critical condition, see energy EC. Okay. So for specific energy, if you remember, we are going to consider only two terms. One is your pressure head, or you can say Y. In addition to that, we have kinetic energy head, that is your V square by 2G. Okay. So Y, as we are going to consider that specific energy for critical condition, so this depth of flow will be your critical depth plus V square by 2G. V square by 2G. That is your kinetic energy head. Okay. Then EC, then we will be having YC plus, in place of V, we can write discharge equal to area multiplied by velocity. So in place of velocity, we can write Q by A. Okay? And you substitute in place of V. So V square, so it will be Q square divided by twice G A square. Or you can say this is also a critical area, because we are going to consider your critical depth. Okay. So this AC is nothing but critical area. It's similar to the area of a cross section of a rectangular channel. Only the difference is you are going to consider the critical depth. Okay. That is why in the next expression, we replace this Q, as we know small q is nothing but Q by B. So Q is equal to small q multiplied by B. Okay. Small q is nothing but discharge per unit width, okay, of the channel. So that discharge you can also write small q multiplied by width of the channel. Okay. So this thing we are going to replace this capital Q. Okay. That is why it's B square by, sorry, B square multiplied by Q square. As this is your Q square, so that is why this will your B square multiplied by Q square divided by, in place of AC we are going to use this expression. In place of area expression we are going to use, so it will be 2G V square multiplied by YC square. Okay. Since Q is equal to Q by B, Q is equal to Q into B. Okay, this is the thing. Okay. Here, if you see in this equation, we have B square here, and here also we have B square. So this will be cancelled out. This will be cancelled out. Okay. So what will be left out? EC is equal to YC plus Q square divided by twice G YC square. Okay. Okay. So for YC, we have derived an expression Q square by G to the power 1 by 3. Okay. That we have already derived. Okay. For critical depth for a rectangular channel, or you can also write like this: YC cube is equal to Q square by G. Okay, that we have already derived just now. Okay, so if you see here, we have Q square divided by G. Okay, so this Q square divided by G, in place of that we can directly write YC to the power Q from this expression, or you can say from 1, you can write from equation number 1, from equation number 1. Okay, So once you put here yc cube and then you have divided by yc square, so it will be cancelled out and will be left out with this is yc cube and we have yc square, then this will be cancelled out and we'll be having yc divided by 2. Okay, so if you do the LCM and you will get critical, sorry, specific energy for critical condition is equal to 3 by 2 yc. So you go through the derivation and see if you are have any doubts. Okay, you go through the derivation once again and see if you have any doubts, then you can ask me, or if you don't have, then we will move on to the numericals. Okay, so remember this equation is only for rectangular channel. Okay, so for yc value for rectangular channel will be q square divided by g to the power 1 by 3. Okay, and for ec is equal to 3 by 2 yc. This is the relationship between specific energy at critical depth or with the critical depth of flow. That is 3 by 2 yc. Okay? So these are the two equations we are going to use to solve numericals. Okay. So see, we have derived that expression for rectangular channel. For trapezoidal channel, you write down the expression. Okay. So derivation is not in your syllabus, but if you want, you can also derive by same way. Okay. The derivation procedure is same. YC, you write down the expression. Okay. Twice q square, because why I have given you this expression. When you go for competitive exam, you have to study for this for other channel section also, like trapezoidal, parabolic. Okay, so at least you write down the expression gz square. Okay, so this is for trapezoidal. Okay, trapezoidal to the power 1 by 5 twice q square divided by gz square to the power 1 by 5. Okay, and ec is equal to 5 by 4 yc. See, rectangular channel is very simple to derive also, and it's very simple to remember also. So, when you go for competitive exam, they used to ask for trapezoidal. Okay, sometimes they used to ask for rectangular, but maximum time they used to ask for trapezoidal. So that is why you write down this expression. For YC, it's twice Q square divided by GZ square. Z, I think you all know. Okay, when you talk about trapezoidal, we will be having side slope, that is 1 is to z. Okay, so that z is this. Okay, 2 q square divided by gz square whole to the power 1 by 5. Okay, and ac is equal to 5 by 4 yc. Then you write for parabolic section, yc is equal to 27 q square divided by 8 gk square to the power 1 by 4 for parabolic section. Okay, and ec is 4 by 3 yc. EC is equal to 4 by 3 YC. Okay. So these things for trapezoidal and parabolic. Okay, you just write down the expression. Okay. So for rectangular, it's 3 by 2 YC. EC is equal to 3 by 2 YC. For trapezoidal is 5 by 4 YC, and for parabolic is 4 by 3 YC. So we are going to end this meeting here, and after 5 minutes we are going to join again, and then we are going to solve numericals related to your specific energy. Okay, so we are going to end this meeting here, and after 5 minutes we are going to join again, and we are going to discuss about numericals related to specific energy. Okay.